So, memory management, how to manage memory in a large memory using applications. In previous videos, we had seen how we can call VIs by reference, dynamically loading them and saving memory. In this video, we will see how we can use code elements that LabVIEW provide that can help us eliminate copies and reuse memories. For that purpose, in this video we will be seeing and using two items that LabVIEW provides. One is called data value reference and the other structure is in place element structure. So let's see. So let's go and create our VI for this tutorial. Let's save it and let's call it reusing memory let's create an icon. Let's clear the existing icon. Let's create a border and let's put a timing glyph. Let's use this template and write a text. Let's call it let's call this timer VI. Okay, so let's create the front panel. We will be using an enum. Let's call it command. Let's fill its elements. The elements that we would be using it inside it would be initialize, start timer, elapsed time, pause timer, unpause timer, shutdown. These would be the different cases that our action engine or FGB would be handling. Next, we will have a control called timers. Number of timers. Let's change it to representation to unsigned signed 32. Next we will have another numeric, let's call it index. Then another numeric called duration. Then we will have some numeric indicator. Let's call it time in seconds. Then we will have a boolean LED. Let's call it elapsed. Then we will have error in and error out. Let's arrange the indicators as well. So now that our front panel is looking a bit decent, let's go and now create our block diagram. So let's go and write code for our VI. Let's arrange the controls and indicators. We will be using a while loop since we will be creating an action engine, an FGV. We will not be iterating through this loop but only once. So let's pass through to it. Then we'll be connecting this enum to a case structure for handling different commands. So let's connect this enum over here. Let's add case for every value. Let's go to initialize state. Then we will have a for loop. In the initialize case, we'll create a number of timers based on this control. And we will be using a shift register for errors. Or rather in this for loop, and we connect it. So this one, this error in, and error out would be over here. Then we will be using new data value reference. We will be using it to create various timestamp constants. This is the data type that we would be creating, and we would be storing them, an array of these. Let's change it to a shift register. And we would also be using initializing an array of change to replace with shift register. Then let's move to the second state, which would be start timer. In this state, we're passing this array through, and this reference of elapsed of timestamp references through. We will index through them since it's an array. Based on the index provided by this control. And we will use another memory management tool, which is called in place element structure. We will be using it for managing two items. Number one would be indexing array and replacing elements. So we will pass it this array and this index, and we would pass this element out. This would also be a shift register. And we will output this into this indicator we had already created called time. So if the time is greater or equal if this time is greater or equal than this duration, then we will be turning on this LED. Next, we will be using um, data value reference read and write element. We'll pass this reference to it. Then we will use get date time in seconds vi to get the current time, and we will replace it inside it, and we will pass the error through. Next, let's proceed to the elapsed time case. In the elapsed time, we're passing this array through, this array of references of timestamps through. We will use an index array function using the index, or rather we will be using these references for indexing through the, we will be through this array we will be using the in place element, in place element structure, same as before. We will add index and replace, so we will index through this array using this index, and we will add this value with get date time in seconds, which we will add data reference read write, and we will use this reference, and we will subtract the current time with the from the previous time, and we will add this value to this array, and another copy outside to the time indicator. And we will also be storing the, keeping the previous time through. Array will also be going through. So let's now proceed to the pause timer case. We'll be passing this references array through. We will be using in place element structure. We will be using index array. We will indexing through this array using this index, and we would also be using our timestamp references using index array function, which will be indexing through this using this index, pass this reference through, and we will use get date time in seconds, Here we will be subtracting the current time from the previous time and storing this time in the array, replacing it, plus a copy will go into this indicator, array will error will go through, and copy will also be saved the previous time. So now we will be moving on to the next case, which is unpause timer. In this case we will take a for loop, or rather this is the shutdown case, in which we will using a for loop to go through each item of this array of timestamp references, and we would be delete data reference value, let's replace it with the shift register, let's pass it through. We would be using default value in this case, also in this case, since we are already closing this loop. And the start timer and the unpause timer would be the same. So we are done with our coding. Let's delete this case. So let's clean up the VI. Let's clean up the block diagram a bit. Let's save it, and we are done with the coding. So let's go and create a test VI. In whose block diagram we would be calling the timer VI. So in the first case we will be calling, let's connect its front panel. So we will be calling it with initialize case, the number of timers we need. Let's say we need one timer. In the second case, we can call it again, and we can use start timer command, and the timer would start. In the and we also send it the index also. So we'll send it index number 1. In the third frame, we could call it again with the command, let's say elapsed time, in which case we will be providing it with the index. Let's keep the index of the timer same, and we will retrieving the elapsed time. Let's create an indicator, and for the boolean, and we will also be providing it a duration. Let's say 1 second. Then in the next frame, we can call this vi again, and we can send it a command of pause timer, in which case that timer will pause. It will also need the index. Let's keep it same. Then we can call it again, and we can call our timer vi again, and we can unpause it. In which case we would have to pass it index. We keep it the same, and in the last frame we can call it with the command which is shutdown, in which case all of the references would be shutting down. Let's pass it again the reference. No, in the shutdown case, we do not need any index. So let's see how our VI proceeds. So let's run it. It's initialized. So the error we got was that we created only one data reference, and we are passing it an array index of 1. this should be 0, which is the first and only timer that we have created. So let's change this, since 1 would be in LabVIEW term second array element. So let's create. So here we are creating initializing. In the second one we're starting the timer, then we are getting the timing, then we have paused it, we unpaused it, and now we have shut it down. And if we go to the front panel and we see the time at that point was 1.98, which is greater than 1, and so our LED was turned on. So this in this way we can use this timer to create this VI to create numerous timers and use it in different parts of the code for managing our different timers. And for that we are using these functions. We are using these data value references, which we can use to manipulate different data items without creating any copies. And we are also using in-place elements, which ensures that no data copies are created by LabVIEW. In this manner we can create memory efficient code.